Let's take a look at these examples. In the first column, we're supposed to verify if connections which are supposed to convert 3-input NOR gate to 2-input NOR gate are correct, and these connections which are supposed to change 5-input NOR gate to 3-input NOR gate. Let me start from the first example. First input is receiving A. Second input is receiving B. The third input is connected to the second input, that's why it's going to receive also B. So at the output, I'm going to have expression looking like this: A, NOR B, NOR B. Okay? Let's organize the expression which is below the negation bar. Okay? If you are going to ignore for a moment negation bar, you are going to have nothing else, just OR expression. Okay? And we have simply A, and I have B or B. B or B, we said, is equal simply B. And now we're supposed to bring back the negation bar, and we have nothing else, just the logic expression for 2-input NOR gate. So I can say that this connection, right, is going to convert 3-input NOR gate to 2-input NOR gate. So I can say this circuit is okay. Let's take a look at second example. Input 1 is receiving A, input 2 is receiving B, and input 3 is receiving 0. So if you want to write the logic expression which we are going to see at the output, we are going to have following expression. We have A, NOR B, NOR 0. Again, we are going to forget for a moment about the negation bar, and please notice that we have simply addition or OR function, right? And simply A or B or 0 is nothing else, just A or B. We ignore 0 because 0 plus A or B is simply A or B. And now we're supposed to bring the negation bar, and we have nothing else, just 2-input NOR gate. So this circuit represents also 2-input NOR gate. So this is also correct connection. Now let's take a look at this one. First input is connected to VCC by pull-up resistor. That's why first input is going to receive always 1. Second input is connected to A, and third input is connected to B. So if you want to write the output logic expression, you are going to have 1 NOR A, NOR B. Please notice that anytime you are going to NOR 1 with anything, you are going to have always 0 at the output. Okay? 1 NORed with, let's say, 0 gives me 0. 0 NORed with 1 gives me 0. 1 NORed with 1 gives me 0. So if you have 1 NORed with anything, output is going to be always 0. And this is not the logic expression for 2-input NOR gate. So I can say that these connections are not correct. So this circuit doesn't represent 2-input NOR gate. So this is incorrect. Let's take a look at this example. We have 5 inputs. First input is receiving A, second input is receiving B, third input is receiving C, fourth input, because it's connected to the third, is receiving C, and fifth is also receiving C. I will have A, nor B, nor C, nor C, nor C. Keep in mind that instead of these three C's, I can write just one, and I have A, nor B, nor C. And this is the logic expression for 3-input NOR gate. So this circuit is correct. Anytime you want to convert 5-input NOR gate to 3-input NOR gate, you can make the connection of, let's say, 2 extra inputs to one of the inputs which you are going to use for your circuit. Let's take a look at the next example. First input is receiving A, second is receiving B, C is going to the third input, and the fourth input is receiving 0, and fifth is also receiving 0. So we have logic expression at the output. A, nor B, nor C, nor 0, nor 0. Okay? We can ignore these two zeros because they are not going to change my expression because I have addition. And I can say that this is equal to A, nor B, nor C. And as you can see, this is the logic expression for 3-input NOR gate. So this circuit represents also 3-input NOR gate.